Hey students, these are the notes for section 1.4, inductive reasoning, deductive reasoning, and then we are going to talk about starting proofs, which will start us with the algebra proofs. Longest part of the notes today is you writing stuff down. So when I tell you to pause the video, write everything down, and then all you have to do is listen to me. Okay, so if you will go to page 8 in your vocab folder. All right, here's the first 4. So pause the video, copy everything down. Okay. And then we have one more down here. Sorry, it's so hard for me to. There we go. Get this one. Pause the video. Okay. So now let's talk about it. You really need to hear me talk about inductive reasoning and deductive reasoning. Okay. So inductive reasoning and deductive reasoning are just ways of making decisions in life. They're the two ways that we think about things when we're making a decision. Okay, so we'll talk about inductive reasoning first. Inductive reasoning is where you observe something and then you generalize about it, kind of think about what's going on, and then you come up with a theory. Okay, in other words, your observation leads to a conclusion. Okay, so for example, my husband works downtown Nashville, so he has found out through experience when he should leave for work. Because if he leaves at 5:50 in the morning to go downtown Nashville, he has no traffic. If he leaves at 6:05 in the morning, he is stuck in traffic. So you think he's practiced this over his 40 years working in Nashville? So an example, determine when you should leave for work based on traffic patterns. That's the key word right there. So the definition of inductive reasoning is making a decision based on patterns and observations. Here's another example. It rained on Monday. It rained on Tuesday. It rained on Wednesday. It rained on Thursday. I think I'm going to take my umbrella with me because I'm going to make a theory that it's going to rain on Friday. Now, is it going to rain on Friday? It doesn't matter if it is or not. We're basing our conclusion on observations. So by me saying, I'm going to take an umbrella with me on Friday, that's just using inductive reasoning. Okay, it's just the way that we reason things out. All right, next we have what's called a conjecture, and these are going to show up in vocab quizzes, so make sure that you know these words. A conjecture is an educated guess. Okay, that's this right here. I think I need to take my umbrella with me. Okay, so Connie takes her umbrella. Miss Ernsberger takes her umbrella with her. Okay, so a conjecture is the decision made from inductive reasoning. Okay, so conjecture goes with inductive reasoning. Okay, then we have what's called a counter example. It's an example that shows the conjecture is false. Counter in front of a word means you're going against the word. So an example is if a food is a fruit, then it is red. Okay, so for me to prove that wrong with a counter example, I need to come up with a fruit that's not red. I said banana. Okay, banana's a fruit, so it's not red. So that proves this conjecture wrong. Okay, so counter example, we may give you something and ask you to come up with a counter example. Another one in geometry, for example, all shapes have 4 corners. Okay, well, I can draw a triangle, and I just disproved your statement by drawing a shape that's a triangle. I could draw an octagon, and that's a counterexample. Okay, so just coming up with something that goes against what you say is true. Okay, then we go to deductive reasoning. I love deductive. It sounds like detective. Deductive, detective, deductive, detective. Don't forget that because that will help you remember. So if you're a detective, okay, let's think this. If you are a police officer and you come upon a crash and you go to see the witnesses and you ask one person, what did you see? And they're like, well, I think that person over there ran the red light. The police officer's going to say, I don't want to know what you think. I want to know what you saw. I want just the facts. Okay, so deductive reasoning is based off of facts. So you have a theory, you come up with a hypothesis, you collect data, those are your facts, okay? So like, I think so-and-so caused the wreck. Well, let's get some facts and see if so-and-so caused the wreck. Okay, we analyze those facts and then we get a predicted result. So what happens here is a specific conclusion follows a general theory, okay? Whereas an observation gives us a conclusion, facts give us conclusion. Observation, fact. Observation, pattern, fact. Okay, and there's lots of things in geometry that we consider fact. Okay, here's an example. If I told you all students in this room are sophomores, okay, and then Jack is in this room, what fact are we going to come up with about these statements? If we put them together, we're going to say, oh, Jack has to be a sophomore. That is using facts that are given to us to come up with a conclusion. Okay, you're going to get lots of practice kind of determining, is it inductive reasoning or is it deductive reasoning? Okay, and then last is we get ready to go to proofs. We will have in geometry what's called theorems. Theorems in geometry are our geometry facts. Okay, they are things that have been proven true. Things that we use to prove theorems are we use definitions, postulates, other theorems that have already been proven true. And so a theorem, the actual definition is a statement that is proven true using deductive reasoning. And deductive reasoning was making a decision based on facts and logic. Okay, so that is all that. A little bit crazy, but when you see what we get into with the work, we're not going to go very deep into this. It's just something we need to touch on lightly. Okay, so go to your notes. They're kind of turned sideways. I'm not going to read all this to you. Just wanted to point out some things in yellow. So yellow, I made yellow deductive and I made pink inductive. So this just has some good examples for you to go back and look at if you need to study. Okay, oops. All right, so let's look at this. So deductive reasoning, to conclude something is true based on facts, definitions, axioms are like our postulates. Okay, so it talks about in this paragraph, Sherlock Holmes, he's going to ask you for the facts. Once he gets the facts, he's able to conclude the identity of the killer based on the facts. Okay, here's an example. Your little brother has chocolate on his face. It's a fact that he has chocolate on his face. So you conclude he must have eaten chocolate sauce, okay, or something chocolate. So you use deductive reasoning to figure out what he ate. You know that all triangles add to 180 degrees, talking about the angles. So one of the key words that we're going to look at to determine if it's deductive is this word right here, you know, or you're told, or you see. Okay, even though seeing is an observation, when it's something that you see only once, it's a fact that you saw chocolate sauce on his face. Okay, so you know that all triangles add to 180. That means the triangle you are looking at adds to 180 as well. Okay, we'll get more practices with those. Let's jump over here. Tom knows that if he misses the practice, so here's that word. Tom knows that if he misses practice the day before a game, he will not be a starting player in the game. Tom missed the practice on Tuesday, so the conclusion is he will not be able to start in the game on Wednesday. See how that all flowed together? These are facts. It's obviously a rule that about this, and then he missed. You know, that's factual, and then so he's not able to start. It all flows together. Okay, in the pink we have inductive reasoning, and that is where we conclude a general fact based on examples that we see. So what happens with this is it needs to be observations that repeat. Okay, so you let go of an apple and it falls on the floor. You do this 10 times. That's repeating. You make a conclusion that every time you let go of an apple, it's going to fall on the floor. It's not going to go up to the ceiling. You can keep trying it 100 times. It's going to fall to the floor every single time. So you make a conclusion. Hey, every time I drop an apple, it's going to go to the floor. That's inductive reasoning. You kick your cat. I do not recommend kicking your cat. And every time you do, so look, every time, that means it's happening over and over again. It scratches you. You conclude that if you kick your cat, you'll get scratched. That's inductive reasoning. You add up the interior angles of 100 triangles. Now I want you to look how this one is different than this one up here. This one, you added up the angles 100 times, and every time you got the angles add to 180. So you conclude that all triangles have interior angle sum of 180. This is inductive reasoning. But up here, you know, you don't even have to do it. You know it's given to you as a rule. That's deductive reasoning. So the thing that is happening in the inductive reasoning is that it's constantly repeating. Repeating, repeating, repeating. Okay, and then look at the pink examples over here. Just one more example. Mia came to class late this morning. Her hair was uncombed, and she's very fussy about her hair. So in other words, she always comes to class with neat hair. So then they make a conclusion that Mia overslept. That's just another example. So let's flip over. We're going to quickly go through these. Here's some more examples. We've already talked about this one. If a quadrilateral has, these are examples of deductive reasoning right here, because it says deductive up here. So if a quadrilateral has 4 sides, then a square is a quadrilateral. Because a quadrilateral has 4 sides and a square has 4 sides, that is deductive reasoning, because this is given as a fact. And then even numbers are divisible by 2. 28 is even, therefore 28 is divisible by 2. These are considered facts. It's given to us the way it's written. It's all about the way it's written. It's written as a statement, okay? And you don't see anything in here about it repeating. Okay, so those are just more examples of deductive reasoning. All right, so I'm going to go through and give you some little tips about words that you can find to help you. Okay, as you walk down the street, you see many people holding unopened umbrellas. The forecast must call for rain. So first of all, that's an observation. And you've seen it many times. It's happening over and over again. So this would be inductive reasoning. I will allow you to put an I or an N, as long as, or an I or D, excuse me, as long as you know I stands for inductive, D stands for deductive. You got to know which is which. Okay, an apple a day keeps the doctor away. Joe ate an apple every day. Dr. Taylor stayed away. Now, this one, it does have something that's repeating, but you have to kind of get the tone of it, that this is written as like a statement that's given to us. An apple a day keeps the doctor away. It's kind of like a rule. So then we have to accept a rule is a fact. Okay, so this is written as a rule, written as a fact, so therefore this would be deductive reasoning. This is like a sign, and if you see a sign, it is posted, and we consider that to be a rule as well. It says all speeders will be fined. Jimmy sped, Jimmy got fined. That's deductive reasoning. Okay, 2 episodes. That little word right there means it happened twice, so it's repeating. Made me laugh and laugh and laugh. Therefore, the Big Bang Theory is always funny. Okay, I don't know if it's always funny. That's kind of a matter of opinion, but I'm going off of an observation that happened. So this would be inductive reasoning. 3, 6, 9, 12, 15. The next term is going to be 18. So this is a pattern that we are observing. In this pattern, we are adding 3 each time. So I add 3 to get here, add 3 to get here, add 3 to get here, add 3 to get here. So I know that I'm going to add 3 to get the next number. That is inductive reasoning. Definitely, if you see a pattern in the problem, it's inductive. All the men in a certain room are bakers. That was given to us as a fact. It's written as a statement. Okay. All bakers get up early to bake bread in the morning. Jim is in that specific room. Jim gets up early in the morning. That is deductive reasoning. We've already had this one. This is inductive. Some of these repeat. We've already had this one. You see it, that it's on his face. You conclude that he has chocolate on his face. That's deductive. And then we've talked about these 2 already, that you know that's a fact. deductive, and then you add the angles up 100 times, that's inductive. And this kind of shows you a little pattern to follow. Okay, now flip over in your vocab to page 11. We are getting ready to talk about the properties and the algebra proofs, totally not related to what we just did, other than proofs are deductive reasoning. All I want you to do on page 11 is to just use any color highlighters, but separate all these so you know that these are all individual properties. We actually have these properties on the next page, but this is kind of a neat place to go look if you need to go back and look at them. Okay, these are properties of equality because they will have equals. These are properties of congruency because they will have congruent. And that little mark right there was left off, by the way. Okay, all right, pause the video, highlight, and now we're going to move on. Okay, so on part B of your notes, what I have done is I've gone ahead and filled in all the blanks. So again, pause your video again, copy all of this down, and then we're going to talk about it. All right, these are the properties of equality. By the way, property of equality can be shortened to POE, property of equality. So we don't just say addition, we say addition POE, addition property of equality. Okay, so what these are the algebra properties. These are the properties that you use to solve equations. Okay, because we can add, subtract, multiply, and divide to get x by itself. We can use the distributive property, we can substitute. This is actually how they're written for the property. This says if A is equal to B, I can add a number to the left and right and it doesn't change the problem. I can subtract the same number from the left and right. I can multiply, I can divide, not by zero though. I can divide by the same number on the left and the right. That is the property of equality because remember what you do to the left, you also do to the right of the equal sign. Equality, equal. Distributive property, you guys know that you would multiply A times B plus A times C, and it looks like this. The distributive property is everything after the word then, okay? That's the distributive property. Actually, it's the whole property, it's the whole thing, but this is what we're doing. Okay, substitution. If A equals B, then A may be replaced by B in any expression or equation. Take out the B, put in the A. Okay, so you're taking one out, putting something in its place. Reflexive. Now, these are the new ones that you may not have ever heard of, so we need to definitely pay attention here. All right, for reflexive, I want you to think of mirror. Because a reflexive mirror, when you look in a mirror, you see yourself. So reflexive is where something is equal to itself. Right now, you just need to learn what it is, and later on, we'll show you why you use it. It's used in proofs, okay? But for now, you need to just know that it's something equal to itself. In like geometry, you might see something like segment AB is equal to segment AB. Okay, something along those lines. Symmetric, I want you to write switch. Okay, the symmetric property says if A is equal to B, then B is equal to A. Now, we've done that in algebra. How many times have you worked out an equation and you had your answer end up like this, and your teacher said, well, we're going to write it like this? You just use the symmetric property. You just switch sides. Okay, you don't have to worry about the signs. You just switch everything and the signs stay the same. And then transitive property, I want you to write train. Transitive property says if A equals B and B equals C, then A equals C. And what happens is we take what we started with and we connect it. So this is a connector. All right, where we're connecting the pieces together, but then what we started with is connected to what we end with. Let me give you an example. If a quarter is 5 nickels and 5 nickels is 25 pennies, isn't a quarter 25 pennies? They're all equal to each other. They're all equivalent. So I can say a quarter is 25 pennies and skip the part about changing it to 5 nickels. Okay? So we will learn to see this also in the proofs. Right now, you just need to know the reason I call it a train is that they are all linked together and you're taking out the middle cars and it's engine to caboose. Engine to caboose. Okay. And what I have here says substitution, combine like terms. I'm actually going to change that. What? Okay, I'm going to change this. I know you don't have white out, but you can cross it out. I like to put simplify. Okay. Simplify, substitution or simplify will work. You're going to see me putting simplify for everything. What happens is if you have, you're going to see this right away in here. What happens is when you have to combine like terms like 2x plus 5x, it's not the addition property. You're simplifying. You're combining like terms. Okay. You are substituting. You're taking out like a 2x and a 5x and changing it to a 7x. But simplify or substitution will be okay. I like to use simplify. So that's what we're going to use. Okay. So let's jump into some proofs. So we're going to be using what's called two-column proofs. In a two-column proof, the left side is called your statements. The right side is called your reasons, and sometimes we will write that at the top. Later on, when we get further into the proofs, we will definitely be writing those at the top. But for now, we're just going to go with what they give us. The reasons over here come from definitions, postulates, theorems, or the properties listed up here. Okay, so the way we do this is we are given something to start with, and we are trying to prove how this ends up. Okay, so what we start with, the given starts here, and our first reason is always going to be given because we have to start with something. So we're starting with 4x minus 1 equals 27. All you're doing for these algebra proofs is you're saying, well, what do I do here to get down to this step? Well, what did they do here to get here? They added 1 to the left and 1 to the right. So they added, so that is the addition property of equality. Okay, so you're looking at this step and you're saying, what did we do here to get here? And then you move over and you put that answer. Well, now I'm here. What do we do here to get here? We divided by 4 to get down here. So that is the division property of equality. Remember, property of equality, we are dealing with equations. So if we're dealing with equations, we're dealing with properties of equality. Okay, turn over. All right, we're starting with a divided by negative 6 plus 2 equals 5. That is my given. So what did we do here to get down here? We subtracted 2. So that is subtraction. Property of equality. And then to get from here to here, this has turned into negative 18. We have gotten rid of the negative 6. So we multiplied by negative 6. Multiplied by negative 6. So this is the multiplication property of equality. So see how we're following? You look at this to say, what did I do to get from here to here? Write your answer. What did I do to get from here to here? Write your answer. Okay, next step. Here's where we start. They distributed the 9. Anytime those parentheses disappear, we are using the distributive property. Distributive property of equality. All right, to get from here to here, we subtracted 27, subtraction. Property of equality. And to get from here to here, we divided, division. Property of equality. All right, next problem. Here's where we started. Okay, so it looks like the 17 is still there, the 7 still here. We've done something with the x's. We have subtracted 6x. Subtraction, property of equality. To go from here to here, looks like we added 17, so that is addition, property of equality. And then to go from here to here, we divided by 2, division, property of equality. And then we switched the answer around to have the x on the left. That is the symmetric property of equality. All right. Last problem. First thing we did, the parentheses had disappeared. That is the distributive property of equality. Notice all of these have POE on them. All right, this is the step that on the front I told you I like to put simplify. So what's happening here is we are putting the negative 7x and the 4x, and we are putting those together to get negative 3x. That is combining like terms. What we're doing is we're simplifying. Just put simplify. We're simplifying the equation. Simplifying the equation. It's also substitution. We're taking out these two and substituting it with a negative 3x, but I like simplify a whole lot better. If you ever put combined like terms, write it out and you would still get credit. Okay? All right. I got to have some questions on here because the whole worksheet has not had questions. I'm getting ready to ask you 3 questions. Give me the answers for number 4, number 5, and number 6. Okay, so it's going to be boom, boom, boom. Give me those answers, and I'll put all the answers. You'll know you got them right in the questions, and we'll be done with the video. Okay, all right. Thank you, students. Answer the questions, and you're done with the videos.